Well, my question is, considering the second stage of our challenge, why is it important to consider different forms of the motor force in the analysis and how these variations affect the vehicle's behavior? The behavior of the car is its position, velocity, and acceleration that come from the equation of motion established from Newton's second law. It establishes that the sum of the total forces applied in an object is equal to the mass times the acceleration of that object. So because the forces acting on a car are represented as the engine force minus the drag force, this means that the engine force minus the drag force is equal to the mass times the acceleration. Then we solve for the acceleration and express it as the second derivative of the position, obtaining the differential equation where the acceleration is equal to the engine force minus the drag force over the mass. The equation for the drag force in our situation where the forces only act in one axis will always be the drag coefficients times the velocity squared. So we have that the drag force always follows like a structure. But in the case of the engine force, the equation describes how this one behaves. And in a real life situation, it will depend on the actions of the driver. So that's why we establish different forms of the engine force, because it can vary in a real life situation. And if the engine force changes, then the acceleration changes, and the position and velocity depend on the acceleration. This is because we use Euler's method to calculate the position and the velocity from the acceleration. For example, in the first scenario that we described before, the equation for the engine force is 2 times 1 minus t. And substituting that value in the differential equation for acceleration, we got that the acceleration decreases at a constant rate, but it starts in positive values. That's why the velocity seems to increase at a certain point, but then when the acceleration gets to negative values, then the velocity starts decreasing. And because the velocity starts decreasing, also the position is gonna decrease, which means that in a real life situation, in this specific scenario where this is our engine force, the guy who was driving the car is driving in reverse. Why? Because the position of the car is going to negative values, which means that it's going back.